For more than a half-century, human beings have stayed tethered to low Earth orbit. Returning a crew to deep space requires an agonizingly precise survival test, one that will push 4 astronauts further into the void than anyone has gone since 1972. The massive vehicle carrying them is the Space Launch System. It is the most powerful rocket NASA has ever flown. And until this mission, the SLS and its Orion crew capsule had never flown with a human crew strapped inside. Escaping Earth's gravity requires converting raw chemical potential into a violently controlled explosion. The sheer kinetic energy creates a storm of vibration and deafening noise inside the capsule, as millions of pounds of thrust rip the massive structure away from the launch pad. In those initial moments of acceleration, careful engineering models instantly give way to physical reality. The math must be perfect, because the astronauts are now at the mercy of the machine. Once they reach orbit, the crew enters a highly scheduled 24 hours of intense work. Confined to the small interior of the Orion capsule, they rigorously test their environmental control systems. Every time the 4 astronauts exhale, they release carbon dioxide. In a tightly sealed spacecraft, that normal byproduct of human respiration becomes a toxic, lethal hazard. 90% of this Orion capsule's life support system has never been tested in space. Mission control requires absolute proof that the CO2 scrubbing systems can effectively clean the cabin air. If the scrubbers fail here, it is an immediate deal-breaker for the rest of the mission. NASA managers wait for a full day of data before making the decision to proceed. Only after the scrubbers demonstrate they can maintain a breathable atmosphere for 24 hours does mission control approve the translunar injection, a final engine burn that hurtles the capsule out of Earth's orbit. With that engine burn, the entire risk profile of the mission shifts. If a major problem develops in low Earth orbit, the crew can turn around and be home in a few hours. Once they commit to the lunar trajectory, any emergency rescue is literally days away. Coasting through the translunar trajectory, the capsule slips into the vast expanse of deep space. With every passing second, the astronauts travel further from Earth than any human eye has seen in over 50 years. In the midst of that growing isolation, a rare piece of communication bridges the gap. The crew in the Deep Space Orion capsule coordinates a direct ship-to-ship radio exchange with the astronauts aboard the International Space Station, sharing a brief moment of camaraderie. This chart shows the maximum distance from Earth reached by human spaceflights. By looping far around the Moon, Artemis 2 pushes the line nearly 249,000 miles out, surpassing the distance record set by Apollo 13 in 1970. Out the cabin windows, the visual reality of that distance is absolute. The blue marble of Earth steadily shrinks into a tiny dot, while the Moon expands until it fills their entire field of view. Breaking physical distance records comes with a heavy psychological weight. The deeper they push into the void, the more acute the isolation becomes, especially as they prepare to fly behind the mass of the Moon, where all contact with their home planet will be severed. The mission reaches its apex during the lunar flyby. The Orion capsule skims roughly 4,000 miles above the Moon, offering the crew an incredibly close, naked-eye view of its barren, cratered surface. While observing a bright spot on the lunar far side, the crew pauses to name one of the craters Carol. It is a tribute to Commander Reed Wiseman's wife, who died of cancer in 2020. To return home safely, they rely on precise orbital mechanics. The capsule must execute a tight curl around the far side of the Moon, using lunar gravity to slingshot the craft back toward Earth. As the Orion spacecraft slips behind the massive bulk of the Moon, the solid rock blocks all radio signals. The crew plunges into roughly 40 minutes of absolute solitude, entirely cut off from the rest of humanity. During that silence, they witness an Earthset, our planet sinking behind the lunar horizon, followed by a solar eclipse. In that moment, the crew is effectively the only 4 humans in existence who can see the sun's light without the Earth in the way. Returning from deep space means colliding with Earth's upper atmosphere at 24,000 miles per hour. That extreme friction subjects the capsule to temperatures approaching 5,000 degrees Fahrenheit, roughly half the temperature of the surface of the Sun. This cross-section of the Orion capsule shows Mission Control's primary concern: the unknown unknowns affecting the heat shield. During the uncrewed Artemis 1 mission in 2022, extreme heat caused pieces of the outer char layer to flake off, leaving deep cracks across the shield. Rather than stripping the spacecraft down to build an entirely new shield, NASA chose to modify the capsule's return trajectory. The new flight path is designed to alter the rate of heat accumulation, keeping the stress within tolerable limits. Flight dynamics and mathematical models can only do so much. The crew must simply endure a blinding 13-minute plunge through the atmosphere, their lives entirely dependent on whether that heat shield fix holds together. The tension breaks only when the capsule slows, parachutes deploy, and radio communication is finally restored. The epic test flight ends violently, but successfully, with a 76-mile drop straight into the waters of the Pacific Ocean. A Navy recovery team, pre-positioned southwest of San Diego, moves in immediately. While NASA is highly experienced at retrieving multi-billion-dollar hardware from the ocean, recovering living, breathing astronauts requires an entirely different level of precision and care. This flight establishes the technical foundation for the missions that follow. The data gathered here on life support and heat shield performance is what makes the crewed lunar landing of Artemis 4, currently scheduled for 2028, physically possible. By deliberately pushing a new spacecraft to its limits and bringing its crew home safely, we have proven that the required technology actually works. After 50 years of waiting, humanity is finally ready to return to the lunar surface.